Hello, everyone. My name is Omar Alomer. That's my name right there. I will be presenting our paper today. It's called the Pastwatch on the usability of provenance data in relational databases. Here's an outline of my talk for today. I will start with a simple introduction. So provenance in databases is basically when we have a query queue, a database D with tables, and the result of that query applied to this database Q of D, we want to find the sources in the database that contributed to the results of the query. Now, to give an example, say we have a database with two tables, a movies table and a directors table, such as this one. And we ask the query select gender with sum of revenue. So we're getting the sum of revenue of all movies in this database grouped by the gender of the director who made those movies. We get results such as this one: male, 229 million in revenue. The provenance of this result is basically all the tuples we see here. All the tuples in the movies table, as well as all the tuples in the directors table. Now, with the representation we use here in our work, it looks something like this. The tuple male 229, as well as the tuples in movies that contributed to that tuple, and the tuples in directors that contributed to that tuple. Now you can imagine for bigger input tuples, provenance could be much bigger. This representation suffers from overwhelming size as well as complexity. What we propose is a provenance exploration system, which presents provenance information without this overwhelming size and complexity. Our focus is on usability in two aspects, mainly visualization and summarization. We identify three main challenges to usability in provenance. First of all, the size of provenance of aggregation query results. Second is provenance complexity. The provenance of a tuple could be it could come from multiple sources. It could be multiple processes, such as joins and aggregation. And the relationship between the results and the sources could also be somewhat complex. Another problem is that we may not know the user's needs and objectives. So now we dive into our system, which we call Pastwatch, which is a provenance exploration system with two main components, a summarization component as well as a visualization component. It has two main features, which is support different dissemination techniques of provenance information, as well as summarizing aggregation provenance or provenance for aggregation queries. User study results show Pastwatch improves efficiency, accuracy, and users found it easier to use. Now here's an overview of our system. I'll walk you through it. The user starts by asking a query queue to the user interface and gets the results of that query back. Now, the user proceeds to select a tuple and ask for the provenance of that tuple. That tuple goes to the provenance summarization component, which pulls the provenance of that tuple and then summarizes it and sends a summary S to the visualization component. The visualization component then visualizes the process that tuple took from the provenance to the result, as well as a summary of that provenance, and shows the user a visual summary of provenance. Now, I'll talk more about the provenance visualization component in Pastwatch. We have three main components. First of all, the provenance graph, which summarizes the process that the tuple took to get to the result. So say with our same query, where we ask for a sum of revenue grouped by gender of director, we have two main tables, movies and directors. that are joined together in an intermediate table, which is movie director, and then aggregated to get the result. Now, this provenance graph should help users navigate the tables that contributed to the results. And there's a data visualization, which is just simply a visualization of query results, which should break data into smaller parts, like this geographical data we have here, which is broken into countries. And then there's a visualization of the summary, which we show here, which is basically a horizontal tree map, which shows rules as well as the score for each rule. And users can use this visualization to drill down on a rule to see more results that are contained within a rule. Now, in terms of summarization in Pastwatch, we look at an example. So with the same query, we're grouping by gender as well, and we're collecting the sum of revenue. Say, if we look at the male tuple with a sum of revenue of 1,088, I assume, billion. So this tuple is actually these 6 tuples here. It's aggregating the revenue of all of these 6 movies. Here's a summary of that table. So we have 2 rules. One rule is for drama movies, and the other rule is for action movies. Now, a rule S summarizes a group of tuples, where star could be any value, and the number at the end is the revenue contributed to total revenue by the movies represented by this rule. The goal of such a summary is to show the user the most interesting rules. So it's not just to group them together, but to actually rank them and show the user the most interesting ones. Now, here's the rule. This is the rule that summarizes all drama movies. And in the work of Smart Drill Down, which we base some of our work on, define interesting as 2 parts. The first one is marginal count, really coverage, how many tuples are covered by a rule. And the second one is weight. Now, the weight of a rule, such as this one, a rule that only has drama in it, has a weight of 1. And since this rule covers 2 tuples, we can say that it has an M count or marginal count of 2. Now, in Smart Drill Down, the point is to maximize the score for the whole set of rules. However, there are 2 problems with that. The first one is that the score function takes the most common values, or coverage. Now, for non-count functions, such as sum or average, that may not work. The other problem is that this function isn't submodular for non-count functions, such as sum or average. So what we contribute is a new score function for provenance summary, which considers the impact of tuples covered by summarization rules. So it's not simply coverage or how many tuples are covered by a rule, but also the impact of those tuples. We use sensitivity analysis, which is a concept that's defined as the sensitivity of a query to a tuple in the database depends on how much the answer changes if we remove the tuple. So say we have a tuple with a movie in it. If we remove that tuple, if it has a high revenue value, then it has a high impact. And this new score function that we introduce is submodular for sum and average, so we can use the greedy algorithm with the same guarantees as we do for count. Now, in terms of evaluation, we conducted a user study where we compared 2 user interfaces, that of Pastwatch, as well as a web user interface where users could enter queries and look at tables. We came up with 3 hypotheses. The first one is that the users would find it less difficult to answer questions using the Pastwatch interface. Second hypothesis is that the users would complete the tasks faster using Pastwatch interface. And the last hypothesis is that the users would answer the questions more accurately using the Pastwatch interface. I'll show you a summary of results, and these are all with varying degrees of statistical significance. Basically, it took users a lot less time to complete tasks using the Pastwatch interface. With 21 participants, you can see the time here. It took them to complete the tasks using Pastwatch, and the time it took them to complete the tasks using the web interface. Now, in terms of difficulty, in here, higher is better. 5 is basically very easy, and 1 is very difficult. You can see the difference between the web interface and the Pastwatch interface in terms of perceived difficulty. And in terms of correct answers, 92% of questions were answered correctly using the Pastwatch interface, as compared to only 82% using the web table format. And that's pretty much it for our presentation. Thank you very much.